So the first equation, how do we solve that one? All right, so subtract 11. You end up with 3x equals -2. So what is x? Right. -2/3. What about the next one? What's the easiest way of doing that? Cross multiply. So this times 2, that times 5 gives you 2 times 2x plus 3 equals 5. Right? That's the best way to get rid of the fractions. So 4x plus 6 equals 5. Subtract 6. 4x equals -1. So x is -1/4. Is that okay? So you should be getting these two questions pretty cold. Now the last one, I'll probably count that one as an extra credit because that's not a linear equation because of the square, right? So that's no longer a linear equation, but you should still be able to solve that one.
Since you're figuring it's going to be 2 times 2 to get 4.
Right.
You divide it by 2.
No. Well, that's better. You'll take the square root because you want to undo the operation. So what is the solution here? Is that it? Right. It could be +2 or -2. So, because again, you're solving an equation, you want to find all possible solutions. If you square 2, it's 4. If you square -2, it's still 4. Okay. So yeah. So that's if you got plus or -2, and I'll give some extra credit. Now I'm going to lose points. But this is the math that happens behind this whole operation. So someone said take the square root, right? Which is exactly right. You take the square root of both sides. Now, what is the square root of 4? 2. Do you agree with that? No questions about that. Square root of 4 is 2. But now, really think hard of what we did last week or so. What is the square root of x squared? Well, not just. What? Yeah, but again, when you take the square root of x squared, it's not just simply x. You should have it in your notes. When you take even radicals, if the powers match, you have to make sure that it always comes out positive. Absolute value. So that's the absolute value of x, really. So that really makes a difference in this case. Because now the question is, what numbers are 2 units away from 0? And that's 2 and -2. So this is how you get plus or minus. Okay? But we will never really going to write the absolute value. We're just going to remember if you solve equations by taking square roots of both sides, you have to remember to toss in plus or minus. No. I mean, you can grab the solution at just 2 points on a number line, 2 and -2. Okay, so we're going to focus more on equations like that today. But again, it'll basically come down to solving linear equations. So we're going to look at 2 types of equations today. So the first, we're going to use a property that's called zero factor property. Or zero product property, depending on, doesn't matter. So that's dealing with equations where one side equals 0 and the other side is factored. So if your equation is of the form a times b equals 0. So you have a product that equals 0. Now if you think about this, when can a product equal 0? Right. you have to be multiplying by 0. You don't get 0 any other way. If you don't multiply by 0, you don't get 0. So if that's the case, then either A equals 0 or B equals 0, or both. I mean, that could happen in some rare occasions. Because you don't get 0 any other way, right? So if you can get your equation into that form, meaning one side has to be 0 and the other side is factored, then it's going to be pretty easy to solve. So all your factoring techniques are crawling back in. We have to be really good at factoring. I might throw another 090 homework at you, because we're just doing factoring in that class. So solve for x. So let's say this is our equation. X times x plus 1 equals 0. What? Well, I'm glad that you felt that it was easy. It would be bad if we didn't. So it's already factored, right? One side is factored, the other one is 0. So my equation is already in this form. So that means I can go ahead and set each factor to 0. So it's either x equals 0 or x plus 1 equals 0. So as I mentioned before, most of our equations will turn into just linear equations. I forgot the equals 0 here, right? We're ending up solving linear equations now. Well, this is a pretty simple equation. X equals 0, done, right? And how about the other one? X equals negative 1. So these are the two solutions to this equation. Either x equals 0 solves this equation, or x equals negative 1. You can leave them like that. I mean, as a set notation, you would say, you know, I wouldn't, don't worry, but just leave them like that. You don't need to get all fancy with notation yet. So yeah, that's fine. Because again, if I take 0 in for x, it's going to be 0 times 1. That's 0. If I take negative 1 in for x, it's negative 1 times 0, which is 0. Right? Does that make sense? So we have two solutions to that equation. Both of them work. Yep. If it's factored. If one side is factored and the other side is 0, then I can just do that. It is very easy. Well, I'll give you something that's not factored and does not have 0 and 1 end, so you have to drag everything to one end to get 0, and then factor. But I'm glad you feel that it's easy so far, and it should feel easy, because if I give you something like that, that should make you happy, because it's factored on one end, and it's 0 on the other end. These are the two things you look at, factored and 0. If it's factored and not 0, you have to do more work, okay? But if it's factored and has 0 on the other end, then you can just go ahead and set each factor to 0 and solve for x, which again, solving linear equations, which you love doing, right? That's the best thing. So you solve the first one, subtract 1, 2x equals negative 1, so x is negative 1/2. Is that okay? So that's one of the solutions. If you plug in negative 1/2 in for x, the equation will balance. This one, you can add 4x to the other side and divide by 4, x equals 3/4. So there we go. We got two solutions. Okay. Any questions on this? Is that all good? All right, doesn't have to be just two factors. Could be more than two factors. Let's say x cubed, 2x minus 1, x plus 3 equals 0. So again, the big thing here is that one side is factored and the other side is 0. So you have 3 factors, so set each of those factors to 0. X cubed equals 0, 2x minus 1 equals 0, x plus 3 equals 0. So what do you think the solution to the first one is? X cubed equals 0. What is x? 0, right? And this one, add 1, divide by 2, x equals 1/2. And that one, x equals -3. So this equation has 3 solutions. Yeah?
So with this one, we see along like the other graph. This one.
Well, I can graph this. The graph, you will learn how to graph this just by looking at it in college algebra. But the graph of this equation will look something like that. It will look like this. That will be the graph of this equation, of the thing on the left. Okay? Let me show you. If I actually plug it on the graphing calculator, what is it? X cubed times 2x minus 1, was it? Times x plus 3. If I graph it, so yeah. It kind of has that big spike in there. But in here is just exactly what I was showing. It kind of goes through the 0 and then turns back and hits 1/2. Right? And that's -3. All right, good. How about this one? X squared equals 2x. What? Well, we don't know that because, again, we just have to operate with what we know, and all we know right now is that. That suggests that, well, one side has to be 0. It's not the case here. So what should I do? Yeah, subtract the 2x from both sides. So it's x squared minus 2x equals 0. Yeah, so you want to move everything to one side if you hope to solve it like that. So, all right, we have 0 on one end, but the other side is not factored. It should be factored. Well, can we factor that side? Yeah, I can just take out the x. X minus 2 equals 0. All right, well, now it's in the form where one side is factored, the other side is 0. So we're going to set each factor to 0 and solve for x. So x equals 0 and x equals 2. How is that? Yay? Good. So if it's not 0, make it 0. If it's not factored, factor it. Any questions on this? How about x times x minus 1 equals 20? All right, subtract 20 from both sides because you do want to have 0. So x times x minus 1 minus 20 equals 0. What should I do now? Open the parentheses because I want my left side should be factored. It's not factored right now because of that minus 20. It's not factored. So I need to open up the parentheses, combine like terms, and then try to factor again because my left side should be factored. So if I open up the parentheses, that becomes x squared minus x minus 20 equals 0. This I can factor, right? How do you factor something like that? What? Well, that's x squared minus 100, right? X plus 10, x minus 10 is x squared minus 100. So how do we do that? Right, we look for two numbers that multiply to negative 20 and add to negative 1. So that's negative 5 and positive 4. So x minus 5, x plus 4. So the product is negative 20, and the sum is the number in the middle. So now we're good. It's factored, 0. So then I can go ahead and set each factor to 0. So x equals 5, x equals negative 4. Is that okay? All right. So to go back to the equation from the quiz, sometimes, because we're going to learn about 4 different techniques of solving these types of equations, and many of them can work. So this equation, I can solve this equation by factoring, right? How do we do that by factoring? We want to make sure that we have 0 on one end, right? So the first thing we need to do is to subtract 4. So subtract 4 from both sides. So that's x squared minus 4 equals 0. Now, can you factor x squared minus 4? Yeah, that's the difference of squares. So it's x plus 2, x minus 2 equals 0. This way, you really see that you get positive 2 and negative 2 as your solutions. You set this one to 0, x plus 2 equals 0. So x equals negative 2, and x minus 2 equals 0. X equals 2. Right? Does that make sense? But in this particular case, taking the square root is a lot quicker and simpler if you remember to make sure you include the negative answer as well. Because what I showed you earlier, if I have this equation and I take the square root of both sides, all I have to remember is that x would be plus or minus the square root of 4. So plus or minus 2. Same solution, right? A lot quicker. So maybe in the case where you have an isolated square on one end and a number on the other end, taking the square root of both sides might be a lot faster. Right? And a lot of times, if I give you this equation, let's say x squared equals 5, factoring might be now a little trickier, because 5 is not a friendly number. But if I stick with this idea, x equals plus or minus square root of 5. So I'm done. There's nothing else I need to do. That's the solution. Yeah. Why wouldn't I? What's wrong with that answer? I really don't want you to plug this in a calculator. That's what you're asking. Yeah, I don't care what the square root of 5 is numerically. Square root of 5 is square root of 5. So this is another technique, and I like to call it extracting the square root. And it works like that. If you have the following, something squared equals a number. So b, the other side has to be a constant. Then a equals plus or minus the square root of b. Well, it's just a number. It doesn't have any variables. Because like what I'm, don't write this down, but if your equation is like that, taking square root of both sides won't help you. You're going to be stuck with the square root of x and the square root of x. But so if you want to take the square root of both sides, one side has to be a constant, or a number, not a variable. So x squared equals 9. Can we use that technique to solve this equation? Yeah. So if x squared equals 9, automatically x equals plus or minus square root of 9, which is 3. Is that okay? How about this one? 2x plus 1 squared equals 4. Can I use that same technique? Yeah, I have one big square on one end and a constant on the other end. Then if I do the square root, I'll just get whatever's under the square. 2x plus 1 equals plus or minus. Well, hang on a second. So do you see I'm really doing the same stuff here? I'm just getting rid of the square. Square is gone. While the other side gets a square root with a plus or minus. It's the same thing, right?
So is that the final answer?
No. Final answer should be x equals 7. That's the final answer. This is not the final answer, but you okay how we got to this point? No, that's the nice thing about that. I mean, you can if you want to, and I'll show you how that works. But so what's the square root of 4? So this means plus or minus 2. So that really means you have two equations. 2x plus 1, because that's a linear equation now. 2x plus 1 equals 2. And you have an equation 2x plus 1 equals negative 2. That's what that means. 2x plus 1 equals 2. 2x plus 1 equals negative 2. Two linear equations. Can you solve them for x? So 2x equals 1. Subtract 1 from both sides. So x equals 1/2. On the other end, subtract 1 from both sides. 2x equals negative 3. So x equals negative 3/2. So the big thing here, if all of your variables under the square, you don't have any other random x floating around, you can just do that. You can get rid of that square by taking the square root, which leads you to two linear equations, which is nice. Is that okay? Because I can do this equation by factoring. Don't write this down, but if I do this equation by factoring. So first I need to get 0 on one end, so subtract 4, right? So then what do I do? Open up the parentheses, so if I square that, so that's 4x squared plus 4x plus 1 minus 4 equals 0, right? Squaring a sum. Combine like terms. 4x squared plus 4x minus 3 equals 0. So now I have to factor that, right? How would we factor that? Okay, so you can do, so what you're saying is 4x squared plus 6x minus 2x minus 3 equals 0. Split 4x into 6 and negative 2. Okay, and then factor by grouping.
Can you just do the 4x squared plus 4x?
No, but then I still have that negative 3 floating around. So that's 2x plus 3. Pull a negative out. 2x plus 3 equals 0. Then pull out 2x plus 3. So that's 2x minus 1 equals 0. So now it's factored. And you said each factor to 0, x equals 1/2. And you said that to 0, x equals negative 3/2. You get the same answers. But it's a little more involved, right? What?
Just being sarcastic about this amount of work, how much this one takes compared to the last one.
Yeah, sure. Well, if that was the case, then Nick would have said, well, that's simply a difference of 2 squares, so I can factor it even easier. Right? I can just say it's 2x plus 1 minus 2, 2x plus 1 plus 2, which is 2x minus 1, 2x plus 3, so it's the same thing as here, if you recognize that as a difference of squares. Well, that's why faster, right? But yeah, so the message here, if you have a problem that has all the variables inside the square already and the constant on the other side, then just take advantage, because this is good. Take the square root, and then that just gives you linear equation. It can be solved like that. It's a little bit more work. Does that make sense? Now, like if I give you this problem, it'll get a little ugly if I try to factor that, because the numbers are kind of weird. But since I only have a variable in one place, and that is already squared, that's the only variable that I have. So I can manipulate this equation to make it look like this, just to isolate the square. So I'll just add 1 to both sides. So that's 2x squared equals 6, right? Divide both sides by 2, x squared equals 3. So I'll isolate the square term, and then just take the square root of both sides, so x equals plus or minus the square root of 3, and we're done. Right? But again, it only works if all the variables are inside the square. So let me show you an example that's really wouldn't work with factoring. Yes, that's an important example. What you should notice about this equation, that all of the variables are inside the square, right? You don't have any more x's floating around. So this technique still applies. I can isolate the square term, just so, move all the constants to the other side, and then get rid of the square by taking the square root. So I don't have to open up any parentheses and try to factor, because again, remember that factoring is a pretty rare occasion. Most things do not factor nicely. So subtract 5 for both sides, you got 3 times blah equals 9. Get rid of the 3 in front, so divide both sides by 3. So that is 3 minus 2x squared equals 3. Okay, so we're isolated that big square. We got it by itself. The other side is a constant. So it looks like this to me. It's of the same format. A square equals 3. Here I have a square equals 3, right? So to get rid of the square, I need to take the square root of 3, And I have to remember plus or minus. So that's 3 minus 2x equals plus or minus the square root of 3. Right? So that means I have two equations. That means I have an equation of 3 minus 2x equals square root of 3. And I have an equation of 3 minus 2x equals negative square root of 3. Both of them are linear equations. Square root of 3 is just some number. It's a number. How would you solve the first one for x? Again, it's a linear equation. What would you do first? Sure, it's a linear equation, so subtract 3 from both sides. So one side is negative 2x. Well, the other side is square root of 3 minus 3. That's what the other side is. It's a number. I don't want you to be plugging that in a calculator. That's what it is, root 3 minus 3. So how do you get x by itself? Divide by negative 2. So x equals square root of 3 minus 3 over negative 2. That's a number, right? That's a solution to that equation. Do the same thing on the other side. Subtract 3, so it's negative 2x equals negative square root of 3 minus 3. And divide by negative 2. X equals square root of 3 plus, x equals negative square root of 3 minus 3 over negative 2. Right? I can actually get rid of all those negatives. Yeah, so all those negatives will just cancel. So that's root 3 plus 3 over 2. Those are numbers. Those are solutions. Those would be really hard to check. To plug those back into your original equation to make sure it balances would be painful. But, hey, you got some ugly answers. That wouldn't have worked by factoring. If we tried this equation by factoring, wouldn't have worked. But we got lucky because, again, all the variables were inside the square. Okay? Is this all right? Because, again, that gave me two linear equations, so I can just solve them. Got some ugly answers in the end. Well, that's where we're at now. So questions on this? No questions? All right, well, start practicing.